Wamsted. This is my house. Oh, man. Wow. I'm so sorry I'm late. I didn't realize it was time for class yet. Whew. Today, we are going to keep talking about parallel lines and transversals, all right? Those parallel lines that run side by side and never touch, and then that transversal that cuts across them. Just like the other day, I've got another video for you from a guy called Mashup Math, all right? And he's going to show you some more about these parallel lines and transversals, review some stuff from the other day, introduce another concept, and then we're going to go do IXL for a little while, all right? So without further ado, here comes the video from Mashup Math.
Hey everyone, thanks for joining me on this lesson. We are going to start out in my home state of New York, home of the Statue of Liberty, the world's best pizza, seriously the best, and the home of the world famous New Year's Eve ball drop at Times Square. Now we are going to go ahead and use Google Earth to take a closer look at the location of Times Square on the island of Manhattan. And now we can see from this map that the roads in New York City make a grid network of interlocking streets and avenues. Notice that our streets run somewhat horizontally and that they are all parallel to each other, and we should know that parallel lines never intersect. We should also notice that our avenues run somewhat vertical, and they intersect our streets in a way that makes them perpendicular or that they form right angles. And looking at the map this way should help us to better understand why, for the most part, Manhattan utilizes a grid system. Now notice that Times Square is located along a street that traverses this grid system. Now you have probably heard of this street before. It's called Broadway. And Broadway is unique because it does not run parallel to any of the other streets on the grid. And when parallel lines are cut by transversals, like in the case of the street map, we have some very unique and characteristic angle relationships, which we are going to go ahead and explore further in this lesson. So let's call an Uber and get out of the city. So now let's go ahead and extend our thinking. We can start out by looking at two parallel lines, and we'll say that CF is parallel to JK, and these parallel lines are cut by a transversal. Now just note that transversals can look a number of different ways. They can even be perpendicular. The point is that the angle relationships will always be the same, no matter how the transversal looks. But for this example, we will look at a transversal that is not perpendicular to the parallel lines. Now, when a transversal crosses through parallel lines, it creates a bunch of angles. And we want to go ahead and explore the relationships between these angles. Now, if we pinpoint on those two sets of angles, we should notice that they look pretty much identical. In fact, if we take our two parallel lines and overlap them on top of each other, we can see that the angle measures for either line are going to be identical. And this is a very important property of parallel lines cut by a transversal. Now, what this relationship tells us is that when we have parallel lines cut by a transversal, we can say that the corresponding angles are congruent. So if our obtuse angle on line CF were 122 degrees, then our obtuse angle on line JK would also be 122 degrees, again because corresponding angles are congruent. Now here comes the cool part. If you know one of those angles, you can find all of the remaining unknown angles. Let's start out with the angles directly opposite or vertical to the angle that we just found, which was 122 degrees. We know that vertical angles are always congruent. So in this case, the angles opposite are also 122 degrees. Okay, I'm cool with that, but how do we find the other angles? Now, we should remember that angles that are linear pairs are supplementary, meaning that they have a sum of 180 degrees. So if one of the angles of our linear pair is 122 degrees, I can find the other unknown angle by asking the question 122 plus what number would equal 180, which is the same as subtracting 122 from 180, whose difference is 58. So now I know that the supplement to 122 degrees is 58 degrees. And again, I know that all corresponding angles are congruent. And I also know that all vertical angles are congruent. So now I have enough information to fill in the measures of all the angles on the diagram. So now let's go ahead and look at another example of parallel lines cut by a transversal. And we'll try to make some generalizations about the relationship between the angles that are formed. So let's just say that we know that one of those purple angles has a measure of 30 degrees. Because we know that corresponding angles are congruent and that vertical angles are congruent, we know that all of the purple angles have a measure of 30 degrees. We also know that all of the orange angles have a measure of 150 degrees because they are linear pairs, meaning they are supplementary. So 180 minus 30 is equal to 150. And again, this should really drive home the fact that if you know one of those angles, you can find all of the angles. Now, since we are all about visual learning here at Mashup Math, I want to share with you guys something that I call the X's and O's mindset. Ooh. This is a helpful little technique for you to better understand the relationship between the angles in any situation involving parallel lines cut by a transversal. Now, this mindset involves differentiating between the obtuse angles and the acute angles using some kind of a diagonal mark. So in this case, I have a diagonal orange streak for the obtuse angles and a diagonal purple streak for the acute angles. Next, I'm going to label all of the acute angles with the letter X and all of the obtuse angles with the letter O. Now, again, you can reverse this and make the acute angles O's and the obtuse angles X's as long as you are consistent. This mindset method will still work. Now, with this visualization in mind, we can conclude that all the angles labeled with an X are congruent to each other. All the angles labeled with an O are congruent to each other. And any combination of an X and an O angle will have a sum of 180. So any XO combo represents a linear pair.
So good, right? Thanks to Mashup Math for that video. All right, we are going to go to IXL, all right? And we're going to do some work, not just with parallel lines and transversals, but also with angles in general. We're going to talk about vertical angles and complementary angles and supplementary angles, all kinds of angles. But anyway, I'll meet you over at IXL right about now.